Section 13.8, Introduction to Complex Numbers. The objectives: simplify square roots of negative numbers, identify the real and imaginary parts of complex numbers, solve equations containing complex numbers, add and subtract complex numbers. I and I squared. The definition of I is the square root of -1, and the definition of I squared is the square root of -1 squared, which actually ends up being equal to -1. So the square root of -a is equal to the square root of ai. By definition, if a is a positive real number, then the square root of -a is equal to the square root of a times the square root of -1, which is equal to the square root of a times I. Note the number I is not under the radical sign. To avoid confusion, we sometimes write I square root a, and that's the pattern that you'll see from me. I'm always going to put the I value in front of the square root. Example 1, simplify each radical. A is the square root of -25, which can be broken down into the square root of -1 times the square root of 25, which is I times 5, or 5i. So 5i squared is equal to 5 squared times I squared, which is 25 times -1, which is equal to -25. That's a check. B is the square root of -36, which can be broken down into the square root of -1 times the square root of 36, which is I times 6, which is 6i. For part C, we have the square root of -24, which can be broken into the square root of -1 times the square root of 4 times 6, which is equal to I times 2 times the square root of 6, because the square root of 4 is 2, which is 2 square root 6 times I, or the way I will write it, 2i times the square root of 6. D is the square root of -45, square root of -45. That's equal square root of -1 times the square root of 9 times 5, which is going to be square root of -1 is I, square root of 9 is 3, times square root 5, which is 3 square root 5 times I, or 3i square root 5. We can write 2 square root 6i and 3 square root 5i as long as we take care not to include the I under the radical sign. I just think it's best practice to put it in front, that way there's no confusion. For complex numbers, the definition is the standard form of a complex number is a plus bi, where a and b are real numbers. A is called the real part, and b is called the imaginary part. If b is equal to 0, then a plus bi is equal to a plus 0i, which is equal to a, and it's a real number. If a is equal to 0, then a plus bi is equal to 0 plus bi, which is bi, and this is called a pure imaginary number, or an imaginary number. So here's an illustration of complex numbers, where a is the real part, plus bi, where b is the imaginary part. The term imaginary is somewhat misleading. Complex numbers and imaginary numbers are no more imaginary than any other type of number. In fact, all the types of numbers that we have studied, whole numbers, integers, rational numbers, irrational numbers, and real numbers, are products of human imagination. Example 2, identify the real and imaginary parts of each complex number. A is 4 minus 2i. Since that is already in standard form, our solution will be that 4 is the real part and -2 is the imaginary part. 2b is 5 plus 2i all over 3. Our solution here we're first going to break that down so that it's in standard form. So 5 plus 2i over 3 is going to be equal to 5 over 3 plus 2 over 3i. Thus, 5 over 3 is the real part. 2 over 3 is the imaginary part. To C, we have 7. Our solution here, 7 is equal to 7 plus 0i in standard form. Thus, 7 is the real part. 0 is the imaginary part. Remember, if b is equal to 0, the complex number is a real number. D, we have negative square root of 3 times I. Our solution here is again going to be to put it in standard form. So we have negative square root of 3 times I is equal to 0 minus the square root of 3i. Thus, the real part is 0, and negative square root of 3 is the imaginary part. If a is 0 and b is not 0, then the complex number is a pure imaginary number. For complex numbers, a plus bi and c plus di, if a plus bi is equal to c plus di, then a equals c and b equals d. In other words, the real parts are equal to each other and the imaginary parts are equal to each other. Example 3, solve each equation for x and y. This is 3a. X plus 3, that quantity, plus 2yi equals 7 minus 6i. We're going to equate the real parts and the imaginary parts and solve the resulting equations. So my real parts are x plus 3 equals 7, and the imaginary parts are 2y equals negative 6. Subtracting 3 from both sides, x is equal to 4. Dividing both sides by 2, y is equal to negative 3. Example 3b, we have 2y plus 3 minus 8i equals 9 plus 4xi. Again, we'll equate the real parts and the imaginary parts and solve the resulting equations. 2y plus 3 equals 9 are the real parts, and negative 8 equal 4x are the imaginary parts. Subtracting 3 from both sides, I end up with 2y equals 6. Dividing both sides by 2, y is equal to 3. And for negative 8 equals 4x, I'm going to divide both sides by 4, so x is negative 2. Addition and subtraction with complex numbers. Our definition, for complex numbers, a plus bi and c plus di. If I have a plus bi plus c plus di, that ends up equaling a plus c, that quantity, plus the quantity b plus d times I. And if I have a plus bi minus c plus di, that's going to equal a minus c plus b minus di. In other words, you're going to put the real parts together and the imaginary parts together. Example 4a, find each sum or difference as indicated. Here we have 6 minus 2i plus 1 minus 2i. The real parts are 6 plus 1, and the imaginary parts are negative 2 minus 2. So we're going to have 6 plus 1 plus negative 2 minus 2i, which is going to give us 7 minus 4i. For b, we have negative 8 minus square root of 2i minus the quantity, negative 8 plus the square root of 2i. So once again, we're going to look at our real parts, which is negative 8 minus a negative 8, plus, and then our imaginary parts are negative square root of 2 minus square root of 2i, which is negative 8 plus 8, and plus negative 2 square root 2i, which gives us 0 minus 2 square root of 2i, which is negative 2 square root of 2i, or negative 2i square root of 2. And again, I would write negative 2i square root of 2. Example 4c, We have the square root of 3 minus 2i plus 1 plus square root of 5i. So again, our real parts are the square root of 3 plus 1, plus the imaginary parts are negative 2 plus the square root of 5 times I, which ends up giving us the square root of 3 plus 1 plus the square root of 5 minus 2i. And here the coefficients don't simplify. This means that the real part is the square root of 3 plus 1, and the imaginary part is the square root of 5 minus 2. So we didn't clean this one up a whole lot.